Okay. Okay, so good to see you again. Why now we move on to a new topic? So right now we'll start to talk about the cryptographic. So all this is about encryption. So we need to know what do we need, and then we will have a like called a symmetric and asymmetric encryption. With different type, and then also another one is called the hashing and digital signatures. So they are all the like really key concept we need to know for cybersecurity, because everything we talk about encryption, right? So that we need to of course some of the I say the methodology like mechanism is more complicated, but some we can know. Now how can we implement some simple cryptographic function in the code? So we just import it, and we need to know the features. So those like will be just like the practice for of like securing the communication in the presence of the third party. So when we sending any message, certain content, data, then we are not only like sending our original the text directly, because I have a middleman. Just like if I have some software, then I will know all your transferring, like I can steal your package. So I can directly look at it and read it. So that's why we need to think about like certain encryption method. It's like, okay, do we have some that means we need to compromise like certain method. Say, okay, if I say A is not really representing A, it may be representing something else. Okay, then that means like both of us. Then we can use a one called symmetric. That means like, okay, both of us have a same encryption method, and then I can decrypt it. Okay, in the same way. Or like, are we using asymmetric? So maybe I'm just this way to telling you, and then I can use another method to decrypt the message. So that's what we need to know. So everything we try to do is like doing is for the CIA. So we're like confidential, and then integrity, and then also the authentication. So we need to think about, and then this is what we need to use for it. So mainly is like what's encryption. So we just like changing our plain text original data into the ciphertext, or the decryption. So we are converting it the ciphertext to back to the original message. Okay. So how can we use it in this like encryption and decryption? We are always coming in pair. I cannot say, okay, let me encrypt it and without decryption. So we have two, you need to know what's the two method, like mainly two categories. What's the symmetric and asymmetric? For symmetric, as well as say, like we are using the same key for encryption and decryption. The most common method is called the AES. The full name is called Advanced Encryption Standard. So we can like use like for the data rest or like file encryption. Of course, if you pay attention when you create a password or like create some certain key, they will ask you what like which kind of encryption method you want to choose, right? So AES, Purdue, and then we have like a new one, and then sometimes we will provide a hybrid. So I think when you choose the key, we have another called RSA, but that one's asymmetric, so you will see the details more. So mainly, how can we do the symmetric encryption? So step one, we need to generate a secret key. So we need to have the key. And then for those data, we like need to have a original input. So we have data, and then what's the process? So are we using the algorithm AES to doing encryption? So just thinking it's just a function. So we need to implement a function, and then you can convert those content to another one. And then later, after we convert it, and what's the encrypted data? So we need to return it. Okay. So for the process, like when we then we talk about encryption, then you need to know how to do it, decryption, just like reverse the process. So we passing the encrypted data for decryption, and then we have the process stream, and we have function, decryption function. So we need to know the secret key. So if we right now we are using symmetric, then I know, okay, we preset, okay, I know this key. So converting it and then using the same algorithm, and then we can recover the original data. So that's how it looks like. Okay. Let's say if I using the ciphertext like original, if I using the AES encryption, I sending a hello. Okay. And then I have a key if I giving in this pattern. Okay. 161, and it's a really long key, and then the ciphertext comes out like encrypted would be maybe in another method. Then how can we do that? First, I would convert this one, the ciphertext. If I need to convert it, okay. How can I do that? I would change to the binary format, and then I would like to change like one key like from original key, and then using the AES key scheduler. So in the initialize one, so we are using the XOR gate to match it with the first one key. And then keep moving on. So everyone, let's say for 10 rounds of AES for the 128. If you see some example like 128, and also we have like 256. Now they put it double, but the processing time it takes longer. As for I remember, have you ever generated when you connect create some server, then you need to have a maybe you will create called the SSH key, the similar. Okay, so you can create your own key and upload it to your server. Okay, for SSH, then you don't have to type your password. Pretty similar what you did for the like when you create the AWS EC2. And when you use the AES 128, then I think it can be within several minutes. But if you change it to 256, that time typically more than 10 minutes. So you have to like wait. So even you change it doubled, but it's a range. So what the process it included like it including inverse shifting rule, and then the sub byte, and then also they are at the round key, and then inverse the mixed column. For this one you don't have to like memorize it, because for the program, if you're interested, you can try to implement, simulate. But right now we do have lots of library. So in the practice, you can try to use the called the library and see how was the encryption return the value. And then in the final one, we'll do like the inverse the shift rule, and then we will have inverse the like sub byte, and also add the round key one more time. So after we process all these steps, then through all the runs, so the final output will goes back to hello. Okay, so we're using exactly same key, and then just using XOR, okay, to convert the text like so many times, like and shift around. So if you know shift is like moving a bit, right? So you know like every time we move a bit and then sub the bit. Okay, so here's all the process when we reverse it. Okay, and then get it. And this one is the symmetric encryption and share the same key. Then we later we introduce the asymmetric. But why? Or like if you look at the symmetric, what's the possible or potential risk if we are using the symmetric encryption? Like if we are using this way to do the encryption, what are the possible potential risk?
Someone needs access to the key.
Expert. Yes, true. Yeah. So here's the idea. Yeah, if when you send it, maybe let's say if I have a communication the first time, okay, I need to encrypt my content. That means I may need to like send you sometimes if we have a standard, or like either I have to tell you what's the key, or what's the standard we are like using for encryption. Okay. Either way, that means like if you are the ones able to steal the key, that means you are able to decrypt it, right? Okay, so after you decrypt it, and then you can pay it again. If I have a middleman, or I'm a attacker hacker, then after I steal information, I decrypt your original message. Maybe I change your bank routing number and account number, and then encrypt it one more time and forward to you. So you think it's true, right? So you think, okay, it's still encrypted, I get the key, but the content already modified, so update. Then we will need to think about, okay, so symmetric, there's a risk. Then we introduce another idea. Okay, what's the asymmetric encryption? So for the asymmetric encryption, we're using different key for encryption and decryption. And then here's the concept that you're using right now. So it's called a public key and private key. And the most common one is the RSA, the reverse extremist argument. So this one may be for the security exchange and digital signature. So when we introduce asymmetric key, that means that even I share my key to you, you may be not able to decrypt the original. Okay, or like if I lost my private key, maybe you are not like able to decrypt. Okay, so or like because I decrypt it or private key, but you don't have a public key to encrypt it back. Okay, so here's the idea, and that's why we need to introduce one. So here's the steps when we doing the asymmetric encryption. So first we need to have a pair of a key called a public and private key pair. And then for the plain text, we need to like do the processing, the encryption. And then the encryption process is like, okay, we need to use the recipient like public key. Okay. And when we need, and then we can like create the encrypted data. And then for decryption, like in the reverse, so once we receive the data, then we will use the private key to decrypt it, and then we will have a output of original data. Okay, so just be careful, like who is, like maybe if you see a question asking when you need to doing encryption, decryption, and symmetric, or like using RSA, then I'm using which key? Like if I need to encrypt it, are we using a public key or using a private key? So you need to like be careful of this part. So if we need to doing the encryption, we need to using our recipient public key. So if we are using their public key to encrypt it, okay. After we encrypt it, then we will decrypt it using our private key. Okay. So that means like if I want to let you send something to me, I will give my public key to you first. So you can use my public key to encrypt it. So once I receive it, then I can use my private key to decrypt it. Okay. Then how it works? Then maybe you raise a question. Okay, if I have a public key and private key, they are not the same. Then how can we do that? Here's the algorithm. So let's say I have a public key and give you the number. So right now you can follow chat. I will give you an exercise, then you can do. And first look at it. So if I give you the public key, 55, n is equal to 55, e is 3. And then private key, that means your private key is n equals to 55 and d equals to 27. And our plain text is hello. Okay, start with hello. And then for the encryption, we start from like 821 30. Then how can we do it? First, like for the ciphertext, we need to convert our all the letters like for the input. Okay, so maybe have a like 7, 8, 21, 13, 24, 17. So started with the decryption. And because we are using a private key, so we using the equation is like C is part of D mod N. Okay, so if we are using the final output, let's say with the 8, and then because we are using private key, N is here like 55 and D equals to 27. So right here we are power that D is all power to 7. And all the numbers will be power to 27 and mode 55. Okay, so if you want to see 8 power 27 mode and two. Let's see the type. We use calculate. Okay, example, it should be 2. And then, yeah, I think I have some typo, but you can follow this method. And then if you like get the digital number, the numeric number, and then we will match it with the ASCII and then change it to another text. So we will be the original code will be another text. So mainly just like follow the equation, it'll be okay. And for the practice, I will let you to do it later. And mainly because once we for the asymmetric RSA is pretty straightforward, so it's easy to calculate. If we are using the symmetric like that one, it's simple, but it's like too much like time consuming. So I'm not really asking to calculate because you need to like taking 10 rounds and shifting. So but this one I will let you to try to using the RSA to encrypt it. So for the text, something like that for text, maybe we will like first step. So we'll convert to the change to the numeric number. So that one will be your ASCII code. So if you know the ASCII code, so here maybe from the ABC. Okay, so right here. And if you know the ASCII code, sometimes if we need to type or like match, so it depends on the tables we are creating. If you see maybe like we can use the ASCII or like we have our own table or list. So I'm telling you, okay, number 1 is representing A, 2 is B, like just keep going on. Then we need to like based on this one. Okay, if after we do the calculation, we convert. Okay, so but this one like we have our own like depends on the standard I give you. So maybe because this one is just like more like a math. So if I give you a list like for the all the numbers like I using a spec just like sequentially like from 1, start from 1 representing A. Then you okay for the 1, then you can do a calculation and convert it. And after you get the return the value and then match with the table. So we say, okay, so I know this certain it represent certain character. And if for more details, actually right here, most of the time we're using, because if we are representing like some character or letters, so maybe we using like from capital A to Z, and or like from lowercase a to Z. Right here will be like 122. Or if we need some special character, sometimes maybe we need like a space or some colon, semicolon, or a comma plus sign. If we need to encrypt all this, then we can also use in a special decimal number to represent those special character. Okay, so later when we have a more example or like doing that's what you need to do later for your coming next assignment, is like doing the encryption like calculation. Of course I give you more example. So today once we move on, so just let you have an idea. So here's the what you need to do is like follow the equation to do encryption and then refer to the character. It's okay. And then after the RSA, more than the actually like apart from the symmetric and asymmetric, actually we do introduce some idea. Okay, so how about combining using both of them? So we do have like for the hybrid. Okay, so when I try to connect or have any idea how can I using the hybrid? Well, like symmetric are using the same key. That means I have a same encryption key. And then for asymmetric, I have a private key and public key to do encryption. But how can we or like increase the security level? It's like I can combine both of them. Then how can we do that?
Isn't the general practice like asymmetric is used for like network communications and like actually like transmitting the data, but then asymmetric is like once it gets to the recipient, then then it's encrypted again with asymmetric to keep it secure on that system.
Can be, but most of the common way is okay, because let's say if I'm using asymmetric, okay, I need to send you the key, right? Okay, and then how about, do you think will I send my key directly to you, or I'm going to encrypt the key? So are we going to do that or not? Yes, right. So we say, okay, I want to protect my key. Like I don't want to, even though we say we have a public key and private key, and we can still remember which key shall send you if I want to let you to send me the message. Okay, okay, yes. Yeah, because I'm sending the public, because I'm sending it like if I'm the one want to receive the message, like anybody using, so we are using sending the public key out, public send to public. And then you use that one to encrypt the data and return me, okay. But when I send this public key to you, okay, I don't want to let others know the key, okay. So because for the key, it can be just some like numbers are showing, okay, like this. It's just a simplified example. So if I want to do that, maybe I can use symmetric, because symmetric is faster. Okay, it's faster than asymmetric. Okay, so I just use a lower security level to encrypt the key. So at least like somebody try to steal the key, they need to spend some time. If they want to decrypt your some message, at least like first they need to decrypt your public key first, and after they get your public key, then they can like hacking try to decrypt your using RSA, using asymmetric. So we increase the difficulty for the attacker or hacker to steal your information. So it's the common way we're doing it, like in hybrid. Okay.
Wouldn't you also have to, so if you encrypt the public key with the symmetric encryption, so wouldn't they also, wouldn't you need to send that symmetric key?
Yeah. So it's the same idea. It going to belongs. Yeah.
So then wouldn't the hacker be able to see that symmetric key to then?
You need to guess. You need to guess. You need to guess. Like you may think that okay, if we look at but when you send it as a package, when you like grouping them, because like when we sending out those information, like for the more like a protocol, like we sending out, okay, first I will send the maybe I will send you the symmetric like encrypted key to you first, right? And then maybe I send the encrypted private key to you. Okay. If you're the attacker, you don't know actually which one is the key, or which one is the like encrypted data, encrypted public key. Actually, you have no idea. So because you're only able to see is like the order package, or like after you get all the package, and you need to like group all those package together. So you just like testing. Okay, I receive the certain content. So maybe you just guess. Okay, maybe this one is the key, or this one is the content. Okay, or like you know. Okay, nowadays probably most of the time should be the encrypted key. Okay, so you need to test like, okay, let me try to using symmetric way to decrypt each other. Okay, so after you decrypt it, you will get the public key, right? So I assume that public key should be correct. And then you will like using the asymmetric to decrypt the content. But it's like you need to go through like 2 steps, and then you don't know actually is which key is the correct one. So you increase the difficulty. So does it make sense? Okay, yeah. And then after that, we have the hashing. So after we this one is like just a simplified example, like telling what's a symmetric. We more like advanced level, we do like using the talk about different, even we have AS, we have different type, and then for the symmetric, we have more other example. But for as an introduction, you just like basically you need to know is symmetric was the example is AS. I think you were able to see it like most of the time. Even before that, we should have 50, maybe this 50, 56. I remember there's a number even lower than 128. Now, but they already fade out. You may be able to still use those encryption method, but they are not strong enough anymore. Okay, and for hashing is another one. Is like process like to convert an input so into a fixed size string of a byte, and then we have the for the output we have called the hash value or hash code. So they will be sending in like hexadecimal format, and those like hash function has the design like to be a one-way function. So it's like inflexible like to reverse the process retrieve the original input. So this one is for the hashing. So if like first steps, we try to convert it to a fixed size like hash value. So it's all one way, and then it's like collision resistant. So it's the characteristic. So if I ask you like which encryption like have a collision resistant, you know it's a hashing function. And then we have a SHA 256, and then that one's called the MD5. So MD5 is the pretty common or we used before to encrypt your password. If you like for other class like web, let's say web programming or API server, if you need to build it, and I'm saying you are not sending the password directly, right? Okay, to your server. Okay, when the user type it, then you will try to encrypt your password, make sure they're being protected. In the old days, like we are using MD5, but because once the hacker will know, okay, because most of the developer using MD5, also like all the library, like encryption method, when out they are kind of like public. So if we have a high chance, we are able to hack the content, so we know. So when our MD5 is, we call the less secure. And you will see like if you need to generate some password, we will change it to SHA 256. So they do have different other bits. One, I think SHA we do still have like 128. It's the same like 256. So it's just like it's a power of the two. Okay. So we can use like mainly you can see the use for the password storage or some like data integrity checks. Okay. And for the SHA like 256 hashing steps, so let's say we need to input the hello world. Then we will first step we will change to the binary. It's like because like all the characters has its own ASCII value. So we can change it. So from the H to like even the commas. So right here, so you can refer. So H it is a capital number H. So it'll be right here. So it's the 72. So 72, you know, we represent using 8-bit. So 7, because the ASCII right here for 8 will be here. So you see the ASCII art will be here. And then the number representing 7, H will be 72. So you will refer it. So it's 001 and then E, and then we have LL, O, and then just like convert everything. So even the space itself, we will consider we have ASCII code. Okay. So you cannot like ignore all those like, if we put the quotation for the text, like all the content will be encrypted. So if you give you a question exercise, don't skip all those like special character. I say the space, some commas like full stop, then you have to also process them. Okay, don't miss them. And then after you convert them to the process, and then we will call the append the padding. Okay, pre-processing. So we will append the single the bit to the end of the message, and then we will append the 0 bit until the length of the message is like 448 mod 512. Okay, and then final step, we will check the length of the original message. So we should be the 64 bit integer. And then later, so the SSJ 256, we start with the specific like initial hash value. So let's say we have H0, 1 to 7. So we have this one, you will see H0 will be like this, H1, okay. The examples right here. And then when we try to start to initialize the hash value, so we'll start with the specific like initials hash value right here, you see. And then we move on to process the data in chunk. So we split the padding message into 512 bit chunk, and then all of them we will create the message schedules. So we'll extend the 16 initial word. So for this word, if you know the unit, right? So we have the bit, byte, and word. So if we talk about word, would be 32 bit, like to represent a word, and then we will change it into 16 for words. Also, all the words also is contain like 32 bit. And then we will have the compression function. So we initialize the working variable from the current hash value, and then we apply the 64 rounds of processing using the bitwise operation, and then modular addition, and then constant. And then finally, we for the hashing final step, we will process all chunks, and then the final hash value will obtained by the concatenate all those like hash variables. And those like binary output to the hexadecimal for the final hash. Okay, so if I convert the hello and then go through the SH256, so it will look like this. So when you put the password, most of the time you will see it will look like this. Okay, if you check some like online, if you have a database and then you look at their encryption method, if they are using SSA 256, you will see every time when you like type your password and then look at your database, if your database have your attribute, let's say password using the encryption, you will see it shows up like this. And you have no way to reverse back, like, okay, I want to see the original content. What's the original value of the password? Because then you say, then how can we know? Then here's the question: how can I know I input the correct password? Well, in the database, like let's say when you sign up the account, most of right now website, it's pretty common for your password you input right now. So after you enter the password, right, and then they were using the SHA 256 to encrypt it and save to their database. So your user, maybe you are using your username or using your personal, like using your email, right, and then with your password. So when you log in, so you will input your email or username, and then you will input your password. Then how can we validate? Because I say the password is not reversible, right? It's not no way. Because for hashing, it's one way. It's one way direction. We're only able to encrypt it. then how can I know you input the correct password?
Like database diff hash values that are people's passwords.
Pretty straightforward, actually. Others get it. Because I say, if I cannot reverse it, but when you input the password, I hash it again and compare with the database hash value. So this is how those websites doing. So I will but I don't know actual password you input. I have no idea. Okay, so even the admin, like if you send an email, can you send me the original password? They have no way to retrieve it. Okay. Even they go to their database, like to retrieve, they only can get this string, the hex string. Okay. And the only way is like once you input the correct password, you will return the exactly same hash string. So you will like, so maybe if you're working on your server side, so most of the time we will compare your server your password in the server side, but not locally. So I will do the encryption by using SHA 256, encrypt it, and then compare the return value. So if they match exactly the same, that means it's the same password. Okay. That's how it works. Okay. So everything is like for the steps, we just input the original and then we need to pre-pause adding the padding. So adding 1 by the end, 0 in the beginning, and then adding it and then process to the 512 bit chunk and then change to like 32 bit initial extended to the initial 16 works to the 64. Just need to know the mechanism because it takes like too many steps. Okay. And you are not required to you just need to have an idea, like the concept is like how hashing is doing one way. And you are not really required, like, or just like for this course, you are not really need to know like how it actually implement. Of course, we can have some function to simulate or use those functions that you need to do. Okay, so for the properties of the hash function, you need to know we need to is the deterministic. So the same input always produce the same output. Okay, so it's important. If it's not the same output, then we cannot check the password. So it doesn't make sense. So we always they have a same output, and then for the fast computation, so it should be like quick to compute the hash for any input, especially for the password, like for login. We cannot taking 10 minutes to like converting the password. So here's the reason why we have different encryption and decryption method. Why we need to introduce like why hashing is useful for most time for password. But when we validate the password, checking the password, we need to do it really quick, right? Especially you need to log in. I cannot wait for 5 minutes to checking my account as a match for helping you like go through all the functions. So we need to like being really fast. And then image resistance. So it will be invisible to reverse the hash to get the original input. So here's the idea, like how we apply. And then why we are not encrypting the message is using hashing, because we need to get the original content. So here's the idea. So based on our need, I see something pops out. Then you should have to decrypt them to agree. Something. You say why, maybe answer the question, why we're still able to decrypt? Okay. Actually, why now all those encryption method, you don't know how much time they spend to doing decryption, okay, and testing. And of course, like for actual practice, like to be honest, like for the academic level, like when you're learning or like open to public, the resources is really limited, like especially you're learning cybersecurity, security. Because like most of attacker, they won't really share like how can they really attack like or actual methods or any method that can bypass. Okay. We do have some like guessing certain theory or like based on some existing. Okay. to be honest, maybe in military level, how many layers? Okay, we say hybrid, right? Hybrid encryption, and you really don't know how many levels of encryption did they apply. Okay, did they using like maybe first layer they're using symmetric and symmetric, and they use asymmetric, go back to symmetric, asymmetric. So they can apply so many layers. We don't know. So for those, like I say, professional, like for those like national, that kind of thing. So like, to be honest, I think they did spend lots of time. So they do it like every day, every second. Like those, like they have a team to attacking. So, but just like it just happened, but you never know how many attempts they did. Okay, or they are fighting you. They were checking the source, and then they were blocking certain connection, and then they were looking for like what. Once they get the information, they want to translate back, like decrypt back to original message. They need to really need to try. Okay, so you never know how many times they did it. So to reverse it, and then the one we talk about the collision resistant, I see. Okay, yes. And then it should be hard to find like two different inputs that produce the same hash. Okay, so here's a called a collision resistant. So just like mainly is like for the collision is like if I have a two different input, but I have a same hash output, then we call it a collision. That means it's possible that means I input my password 123, and then you input the password ABC. But if I generate same hash output, then it causes a collision. That means, okay, even I input a wrong password, I can still able to log into your account. Okay, so that's what we need to prevent. That's how the hash is doing. And we do have different type of like the cryptographic library. For mechanism for the exercise you can do, but for the lab, and then I just like want to let you know we can when you need to implement or like handle certain data, try to use library. You don't have to really say implement your own function. Of course, if you two of you want to do that, yes, like okay, let's like create a new communication encryption method and then share the key, increase the security. Then yes, you can do, and the cryptodome or like the OpenSSL, and use those libraries to offer the writing algorithm from the scratch. You don't have to do that. Okay, so you can just input password parameter, or just use those library directly. So everything right here will be just need to know have an idea what's encryption. Convert the plain text to the ciphertext, and decryption we like convert the ciphertext back to the plain text original, and then we always have a key like in our encryption and decryption process. And if in the network nowadays we need to transferring the key to our destination, so if we need to apply those like asymmetric, then we need to send the public key to the sender, then we can receive it and decrypt using our private key. So you can still exploit. I try to work on my environment slightly crashed, but I have two Python code uploaded. But if you can fix, you can try to import the one that AES. For the hashing is pretty straightforward. Let me copy. Okay. Let me add it. Okay, and if you are for different programming language, we do have their own library. Okay, so if you are working on the Node.js, and then you can also go to check some library for encryption like hashing or hashing or AES, those encryption method. And this one I'm using the Python as an example. So if we have the original like data, then we can call the function. You can use all those libraries, they will give you different type of encryption. Even you can choose the SHA 128 or 256. After we encrypt it, we could call the function, have a library, and then return the object, and then with the hex digest. And then for this one, the digest will print out the hash message. So I will execute this one. Will be hashing. Okay. So it would be like this. If you do download it, I would like to let you to just for your exercise. I create a discussion. So if you have the Python, you can execute it. If no, you're welcome. If you do have a Node.js, and also you can try to implement it. Okay. So you can try Node.js hashing library. So just Node.js hash. Okay. So you can see Node.js, we do have the cryptos method. Oh, let's see. We can use this one. So we have the syntax. So we can use like to create the cryptos right here. And then we have a key digest passing. So I would like just like this. Let me save it. Okay. JS. Okay. So all of this, they are working very pretty similar. And just like original text, and then we just encrypt it. Okay. So let me execute this Node.js. Okay. So it still do the same, and then we can try to change the original message. Let's say I changed the Python code. If I change something, is the and then I add CSCI return, then add today's date. Then, save it. So here the return value. Okay. You will see the pattern, and then the tricky things like if I only change the input message, because I keep the previous right here. Even you will see like this is right. I keep the same first like two words, they are exactly same. But you will see when we have a returned and like return the hashing value right here, they are not starting as the same. So you cannot say, okay, let me guess. Okay, are they the same patterns and they have a return value? They are the same. And we have no way to do that. Okay. When I'll give you some time to practice, that depends on if you want to work on the Python. Python is okay. Node.js, you're welcome. Just like download it and execute it. So I only want to let you to like feeling how can you using those encryption. So remember right here, let me copy the original code right here. And mainly you need to import those like the crypto library. So like I say, as far as a different language, we do have their own library you can choose, and then you can define what's the library algorithm you're going to use. So mainly we are using SHA 256 for password, and you can change the key. So this one for your exercise, I create a in-class exercise, so you can do it because for you like get some extra points. So you can, after you finish, you can upload it. Let me, like have encryption. Let we suppose, so you can submit it. Okay, so you can execute, and then you can change the key or the content you're using, and you can try to create a hash. So mainly right here, you will see the create hash. So we pass the algorithm. Okay, of course, you don't have to declare the algorithm. You can pass the SHA 256 right here, and then update the key. Is the content you need to pass it, and then digest. We are converting to the hex. So it's defined. And then we will change the hex to the base is like 24, then we can digest it to the 64. So this like two outputting content. Okay. So if we stay on this one, hex is be the hex. From the hex, we convert to base 24 will be letters, character. Okay. So for other exercise, if I want to ask you, okay, please show in letter, then you need to remember use the base 24. Okay, base 24 is the change it to the letter. Okay, from the hex to letter. And if you, I think if those you are already installed on Node.js, then I would recommend you can using this one. I will post this one, and then you can just replace the key. Replace the key, your own key, run it. Okay. Just need to make the, just like for some exercise for you, so you can run it and then screenshot your output and then upload it. It's okay. Just like give it some exercise to use. Okay. So while you're doing this, I would like to talk about the let you to start to prepare the project. So for the project, what you need to do, let me okay, I have not yet uploaded. Let me see. Okay, it's right here. You can because I know maybe well for this class like cybersecurity as well mentioned, because maybe not all of you like maybe good at programming or like still learning. So you're allowed to like form a group and together. Maybe I know maybe not all of you have I know the AWS EC2 is not always working, lost connection. So you can form a group and then like using the AWS. And if you still remember, I give you those like all the source code, right? So about the injection or XSS, you still remember our like reflect the XSS, store XSS, and then the DOM base, all those. I did give you some example. Okay, so I just make sure of you try to compile the code together and then make it running as a one server. Let's say the XSS, you see all the happy.js the code, right? So try to create all the path, and then first like make the path have nullability. So it's like that means we have like this exists. Okay, so make that you can do the testing, and when you need to do the testing, okay, if I this one is specific for the store XSS, so how can we attack it? Okay, so we can do the input, and then the as a follow then what kind of prevention we can do, like if I want to protect the store XSS, maybe I need to replace the character, or based on the situation, actually you will see for reflected or for the input, you can use the library or calling the function at the called the escape HTML to convert the input, because we convert the special character to string. So you know when we replace it, actually we place those characters to the ASCII code, like you will see the special HTML numbers. So we convert those HTML number, you can see the output. So we won't treat it as a script, but it's just a plain text. Okay. So for the project you can study, and then after you finish, what you need to do just like make a report to like telling, okay, so screenshot everything, and then provide your source code, and then what kind of prevention action you you implement it. After you implement it, and then you just need to have a report just like discuss. Okay, so but just more like a knowledge. It's kind of helping you have a revision. And then I will welcome and later I will open if for the teams. I will let into other teams like if you can add one more part. So letting is like is a bonus is you can like try to open a certain periods like before you implement. Or like you can check in. So I have a previous like still have a notability. So you can go to access their server like with the like access attack. Try to perform certain accesses attack and then get the result. Also, you can say, okay, I have a IP address and the SSA, so you can see you're able to perform certain attack. Okay. Yep.
For the overall class, I can understand concepts that you explained for the XSS attacks and whatnot. The hash tables, the cryptography, I can understand the concepts of how everything is working. Well, whenever you start to go to the code, I've only gotten there's no other prerequisite class up till now besides base programming, and the only thing that's taught here is C++. And so I don't have an understanding of whenever you go to the HTML or you're talking Python.
Okay.
I'm not versed in those because it's not something that I go seek out on my own. I mean, it's just not something that
I understood it.
So when it's, oh, hey, go test for this, that, and the other, and you're talking, just, hey, go, I'm giving you the code, but I don't know how to use the code, right?
Okay, for the project, like for the coming several weeks, then I will go to like, actually I will do a demonstration. Okay, I will helping you like, what do you need? Yeah, okay, yeah, don't worry about this one, yeah. Because I know some of you already know certain way to do that, then you can like just start it. Because I want to like tell you earlier, but if to some of you say, I really no idea, because like for cybersecurity, I'm not really fixed to certain language, but like for all language, we can do perform like attack, right? Just like but everything I'm using, so even for this the project, just like combine all the previous exercise or like in the class I have some demonstrations. So I will like guiding you how can you set up, make sure the server is working, and then how can you like make sure those code is executable or like make them launch. So for the coming week, I will spend some time to like have tell you how can you set up. Okay, one by one. One of you maybe have an idea, like if in the previous class you still have some idea, I show you some demos how they work, then now I help you to set it up. Okay, so I'm guiding you to set up those the environments or like how to let those source code like be executable. Okay, okay, so don't worry about that. Also, if you need some extra time, I'm welcome that you can set up the some appointments. I can help you to if you're interested. But I know maybe not all of you like say I'll be to do practical, but for the class I know in lecture you prefer some like theory and there's some idea, but for practical maybe not all of you like want to do that. So so I for the project I will include part of like you can just execute. If I give you all the even all those like prevention, if you look at the comments, all those syntax, like if you look at the content, I give you all those like solution attached together. But the question I ask like how can I make those like I given those solutions, how can you use that? Maybe you I try to let you have some time to study because it's a process, it's a study. If I give you everything, then how can I apply? So I say try to learn how to like if I give you everything, but I don't tell you exactly the solution, then how can you put up or like even copy and paste, you know where how to place it, right? So I give you some time to do that, but because I know for this class, it's much more like introduction, is there some basic or also you are not learning programming. So I will tell you how to set up. So most of the time, maybe after you set up everything, maybe just writing a report, okay, discuss, okay, so what's the potential risk? So what's the prevention, how this prevention work? And then you can discuss like in future, like, or like nowadays, actually most, everything right here is open to public actually many years ago. Yeah, so we know all those bits, right? So we will try to introduce different encryption method and then prevention. Even it's really hard. Even we talk about the SQL injection, maybe a long time ago it worked, but right now even the database, the system itself, also they will detect it and prevent it. So it's really hard. So they, for the attacker, like I say, professional level, they do try other method, like different way to attack it. But for a student, like we know, okay, we have idea what's SQL injection. Like based on the same idea, SQL injection, we have another like professional way. They won't share or like open to public, like except those like professional hackers. Then they will try to do. So you just need to have idea. So but why now I want to let you know earlier. So this is the structure of the project. Just like apply all the source code I gave you, and then to build the server, and then you can test it, doing test. Okay. So if you're forming a team, some of you know how to do that, then you can just form a team and running one server and doing testing and then write the report. Okay.
So we can form our teams.
Yes, yeah. Yeah, you can do it. Yeah, so if you want, you can do it. And then I think I already created a group, so you can join the group, pick the number. Yeah, 3 to 5 students can work together. And here's a 2 parts of it. And this is, so I'll give you the time. So if you want to execute, and then you can upload your result, just make a screenshot. So just showing the origin. I would like to, let's say right here, if you're using, so original, let's say the key. Okay, so maybe you can like show me the screenshot. What's the original input key, and then encode it. What's the result? Okay, so here's the like the sample output. If you don't know the syntax, always try to look at the structure. This part is not about like cybersecurity, but if you want to really learning, or if you want to be a software engineer, like programmer, developer later, yep.
I clicked the wrong group. How do I get out?
I will help you, but you can come out. After I disconnect, I will help you to remove, and then you can join it again. Okay, and this slightly not in the topic, but if you want to learn, because I give you the sample code, maybe you have no idea what it's doing, but I will tell you something is like, maybe this one is called the console log, right? So you will, if you have no idea, but you install the Node.js. If I want to print certain message, they are looking, okay, I'm asking try to print a message, and I tell, okay, follow the syntax using the console log, this function. So it's printing is similar to C purpose. So it's like called the cout, right? So it's for the Python. How can we print? Anybody know the Python? I know some of you learn. It's print, right? So we're print that. So it's a pretty similar idea. So and it's the same. If you're learning one language, when you're master of one language, it's easy to pick up another language, because like we do have something shared idea. Come on, like we do have a print function. Then if you forgot, like let's say if I use several language in the same time, sometimes I did like I need to use multiple language, I mix up the syntax. But at least I know I have a print function. Then what's this print function used for this language? Then you can Google it. Okay. Or like I need to write a for loop. Maybe I'm using, if you're using Python, you know you be using the for, or the Node.js, I tell you we have the for in loop. So all the syntax similar, but we know we have certain function. So right here, if I ask excuse me. So if I asking you, try to print out the message with the original, what's your original data? What's the original content? just copy the function like, you know, console log is printing, and then I know the key is my original content. And I just put a key right here. Done. Right, then I can print out the original message. Okay. And this is the exercise for you. So you can just say, if you finish, then you can upload, yes. Just screenshot is okay, yeah, yeah. You know, just like let you have some exercise like practice, yeah. And then later, I will add more, like change more for your project. I will add part of it is like for report is like you can talk about this encryption method or like about the access and all these things. Definition, your idea, personal opinion, yeah. So then let you have a better understanding of this like cybersecurity things. Yep. And then I will help you. You make them.
Visible window.
Let me stop sharing. Let me see.
I can be fully on desktop.
Okay.
I'm in group one.
Group one.
To be in three.
Three. Okay, I will remove. Give me a second. Let me answer that question. So if you want to run the file, at least you need to have installed the Node.js or Python. If you don't have it, I can share this one. Okay. Therefore, some of the program like Happy.js, if you need to execute, you need to install. So depends on the system, you can like install Node.js. That's what you need. So you can directly download it or follow the instruction right here. So if you're running on the Windows, then you can on Windows like copy the comments right here. So the first three line is try to install the Node.js, and then these two Node that's we like having via npm is checking the version. So if you install them successfully, then you should able to execute it. And when you have a JS file, so you can using the run Node.js. So it's similar to mine. So I using Node and then execute the crypto.js and that's how it works. And we are using a lot, so I will recommend you instead of Python, then you can install the Node.js. Because I know some of people they are learning Python. Then if you do have it, then you can execute directly. Okay. I wish I can. Okay. Okay. Yes, I forgot to share the screen. Okay, I'm so sorry. Okay. So if you want to like follow my you can type the Node.js. Node.js install. I'm showing you the Node.js right here. So you can choose the environment. So I recommend like maybe you can use the current one, the latest one, and then choose your system. If you're using Windows. If you're using Mac, and then Mac. Okay. If you want to running on the server, then Linux, and you can choose Linux. And I assume if you're working on the Windows, will be the first three lines statements will be right here. So just get it and then get the environment, then you can install the Node version. Okay. If you're using a Mac OS, you can get it from the source and then assign the FFM to your terminal, and then you can install it. So you will see the Node.js. And after you install it, then you can execute it directly. So I can code the node and then execute my file. So I can execute one more time. So you will get output. And then how can you validate if you install correctly? Then you can use the node-v and npm-v like this. If they show the version number, that means you install them successfully. So we can try to install it and try to do that. Okay, I will help you to. Let me stop sharing. Okay. Let me unplug it so I can help you. P2M right here. So your mistake is the group. Group one, and then you want to go to group three. Okay, view environment. Let me see. So let me see. So you were
Toyo dealer.
which one?
At the bottom.
Bottom page 2. Let me see page. Okay, right here. Okay, so save. Okay, I can help you to so go through it. Right? Okay, so I can help you to answer and the word directly. And next page is right here. Okay. Okay. And you can check it one more time and then see. And then okay,
thank
okay,
you.
it's good. And let me see. How many students? I know Thursday is Halloween. No candies, but seriously, but I will give you the option choose. I don't know. I don't know if you want a party or somehow, or like, I know some of you have whole days. I can change to online, or you want to have in class. The one is like stay in class or like switch to online. Okay, I know. You are not pretty late. I'm not sure. It's mainly I told you to give it for you get everything. Okay. Let me stop and I will check it one more time and. That's when I grading, I know some of it. I only look at the key points like if I for the certain things. And if you make one mistake, like you are given the so if you couldn't like get the correct one, so I give you that one. And if you make more than 10 or whatever, I won't like that. You go for the low pass.
That's why.
30, but if you make one mistake, like or the like, then I will just deduct for that for you can see let me check. Maybe let's say if for some certain like I don't care the good or others, maybe I look at let's say. So if you only push but it's only readable for but for the I just like make sure process used to be maybe if you forgot. I need to check your wow. Okay, let me stop the sharing.